So let's do these examples. And then obviously we need to find the values of these functions when x is 4. So in their simplest form, we get f plus g. They're saying find f plus g, f minus g, fg, f over g. Given fx is 1 over 2, gx is square root of x. Okay, and then we should also find, just an example, the value of this one. Now, these questions are always going to be given in this format, the simplistic ones, but then we'll look at the more difficult ones as we go. Okay, so this is the first example. Okay, hope we've taken note. Okay, so operations on functions are quite straightforward, except when they begin to combine them. So these are probably the only example that we need to do on operations. So we can add functions, we can multiply, we can divide, we can subtract. So we're just going to test one, okay? And then the same concept can be applied on all of these, the multiplication. And so they're saying find f plus g of x, given that function of x is, f of x is 1 over x minus 2, then g is x, gx is root x. And they're asking us also to find this value here. Okay, so let's do this first example and then we'll see. So they've asked us to add those two functions. What's the first function? The first function is f of x is 1 over x minus 2. And what was g of x? G of x was root 2. So what do we do when we want to add these two? So we'll say we said that this is the same as, let me write it. So we said that if it's like this, okay, it is the same as f of x plus g of x. So by now you should have gone through the theory and known what is going on here. So we're actually going to add now, because you always need this form here that shows you the operation itself. So we have 1 x minus 2, then we're going to add root x. Okay, in some cases this is already a rational, this is already rationalized. Okay, so it's okay, we can leave it there. And then the second part of this question was, so that's our function here. So if you can write it to say if f plus g of x is going to be that function. So now they asked us to say, can you find this same function, okay, at value 4. So what do? We just go and, because now we're not replacing the whole function, we're just replacing values at these points. Root of 4. So what do we have? We have 1 over 2 plus 2. So our answer is going to be 2, 1 over 2, or 2.5, like that. Okay, here's another question. They're saying let fx is equal to x squared and gx is equal to x minus 3. Then let's find f of g and then g of x. So this is, now you have to realize that this is combinations. It's no longer just adding. So this is where these are compound fractions now. We are not just adding. So these are compound. Now let's do f of x is our main function. The first one is always your main function. The second is going to be a factor of the second. So here we say fx, we start like this, is equal to x squared. Now they're telling you that x here will not be x, okay? It will be gx, okay? So f of g, you always have to, x, you always have to make sure that you first characterize it into a form that shows the algebra, okay? So here now we're going to say this is going to be f, then we're going to have gx inside here. So this turns out now to be, we're going to have x squared. We know that this is our main function. So we're going to take this guy, the gx, right? And then we're going to square it. So this will be our f of gx. Then if they came and said, now show us the opposite, then we're still going to do the same. We're still going to go to g as our main function, which is going to be x. Now we know the x is no longer going to just be x. So it will be x, okay, squared x squared, that's what has become x, the power of 1 minus 3. So that's substitution. Then we have x squared minus 3. That is different. Then they said, let's find this when it's 5. So we're using this fraction, right? The function. So we're going to say f of g x, this time is going to be 5 minus 3 squared. Then we have 2 squared. That will give us 4. Okay, so this is a little bit different. It says if f of x is root 2, g of x is root 2 minus x, find f of g and f of f. So this is what the focus is on. So let's do f of g first. F of g, this is going to be f. We put it in a format that's algebraic, like that. Then this will become f. F we know is root 2, root x. So we're going to have root, we know this is where we'll put our values. Then where there's x, we're going to put gx. So meaning that we're going to have root inside here of 2 minus x. Now, this is not in a format that is presentable, so we need to change it into the format that is presentable. Remember, we go back to our radicals and all. So this was, we'll do it step by step. So this is 2 minus x. But where is my first radical? My first radical has gone outside here. Okay. Then I also make this into a radical, into an exponent. So that becomes 2 minus x. I have a half from this one and a half from that one. So those two, they multiply. Then I get 2 minus x, then 1 over 4. So this is going to be 2 minus x. So that's my f of g. Okay. Now, what about f of f? So f of f is going to be a little bit different. So f of f of f becomes f of fx, like this. Then this, we look for the function itself. That's the function. So we're going to say this is x. Then we've changed x to that. Okay, so now we went through the other process, which gave us something like this. Then we're going to normalize this to this. Okay, so if they gave you a value, and remember these will have domains, but we said that the best way to look at domains is to know what you're avoiding. So what we're avoiding here is all negative numbers. And then from there you can form the domain. Okay, so now these things can get a bit complicated, but you just need to follow a proper sequence. Once you can sequence what you're doing, everything becomes easier, right? So sequence is everything when it comes to these things. So let's try this one. Okay, so f of g of h. Okay, so we have a setup like this. We have f like that, like that. So the big question is, what will be the sequence of events here? You need to have a strategy or a plan. So the strategy is you're starting from here, you're going to that one. Once you get from here, then you go from there. You don't start these from here. So you make this conversion from here. You convert h into g and g into f. That is the strategy that we need to be able to understand. So let's begin with g of hx. Okay, so this one will give us what? Will give us, we have hx goes into g, so this one goes into that one. So we'll have x plus 3 power 10. So we have our first movement. Then this is our new function that we say is sequenced to now go into this one here. So we take this whole function here and put it wherever we find the input or the variable, which is x. So we're going to say g. We're going to say f of g. So we're going to say f of g of h, therefore becomes f of gx, because we know what gx is. So now it will be x plus 3, okay, power 10. Then what do? We continue, look for another place where there's a variable, which is x plus 3 again, 10. Then where is our 1 going to be? It's part of the divisor, so it's going to be like that. So this is our full f of g of x. If they gave you a value that you need to put in now, maybe let's say find f of g of h at 0. So this becomes 0. This one becomes 0. That becomes 0. Then you complete it. So this is it for the practice that you may need when it comes to algebra on functions. All the best again in the studies. Cheers.